What's going on, guys? Einstein here. Today I was playing around with some of those voltage reference modules and I decided to record this video to show you how precise they are. They are quite cheap. This one costs $4 free shipping, and this one $2.30 also free shipping. They are based on AD584 Voltage Reference. That's this sealed chip here in the middle of the modules, and this one is a variation L of this module, as you can see here, 584L. And this second one, let's get in focus here, is the variation J. In the Chinese market you can find variations J, K and L of those modules, and they claim that the variation L, that's this one, is the most precise. So let's check that out. They both work with inputted voltage between 4.5 and 30 volts, and they have 4 output voltages: 2.5, 5, 7.5 and 10 volts. The second one here is the same: 2.5, 5, 7.5 and 10 volts. So if you provide 4.5 or 5 volts less than 7.5 and 10 volts, those modules they have to boost the voltage somehow. So let's check this as well. I will be first powering up this module with 12 volts. After we can try 5 volts. And this module here has those battery terminals, so we can supply the power to those battery terminals, and also this power connector. So I have here a battery pack with a power jack connector. It's 12 volts, so I'll be also trying to perform some tests with this battery pack. So let's start with this one. This one has a on-off switch. This one doesn't have, and this one has a small SMD LED to indicate when the module is on. This one has an LED in here. By the way, in this specific model I have this LED is not working, but it's not going to affect our measurements. And this one I have the output terminals in here, as you can see. And this one we have the inputted voltage in the left hand side, so V in and ground, and the output voltage in the right hand side, V out and ground. Okay, so let's start with this this first module, and let's see how accurate they are. I recently calibrated my benchtop multimeter, so I can trust in this one, but I'll be also using at least for the first module, I'll be also using this handheld multimeter. So let's turn it on. Let's put in a position that you guys can see. Okay. So now I'm gonna hook up my benchtop multimeter in here. So here I have the negative terminal and the positive terminal here. So benchtop multimeter is already connected. For the handheld multimeter, I'll be using the connectors in here. So let's now connect our power supply. So I'll be using the battery terminals in here. So as I said, they're gonna provide 12 volts. So let's put 12 volts here in the power supply. And let's turn the power supply on. Let's hook up in here. And now let's turn the module on. So as you guys can see, 2501, and in the handheld multimeter, in the benchtop multimeter, sorry, 2501 as well. Now let's turn off and try 5 volts. Again, connect the handheld multimeter. Let's turn on. So at 5 volts, 4999, 4998, 4999, and my benchtop multimeter 5002. So it's quite precise, this module. Now let's jump to 7.5 volts. Let's turn it on. 7502, and my benchtop multimeter 7504 and 9. And the last output voltage is 10 volts. Let's hook up here and on. So 999, and my benchtop multimeter 100029. Now let's see at 10 volts. Let's change our supply to 5 volts, because in this case the module has to boost the input voltage to provide 10 volts in the output. So now I'm providing 5 volts in there. So let's turn on. And here, as you guys can see, the output voltage is just 4115. They are supposed to work between 4.5 and 30 volts, but I'm providing 5 volts now, and as you guys can see, the output voltage is not 10 volts. Let's see, at 2.5 volts, for 2.5 volts, okay. Let's see, 5 volts. As you guys can see, 5 volts, it's providing, the output is 3.9 volts. So even though they say that you can put any voltage between 4.5 and 30 volts, that's actually not true. Let's try a higher output voltage, let's say 7 volts. Let's try, the jumper is in 5 volts now, so let's try 5 volts. So yeah, now with 7 volts, the output is 5004. Now with 7 volts, let's try the 7.5 volts output. So as you guys can see, it's 5.9, so it's not outputting more than the input, so this board doesn't boost the input voltage. So it should provide always more than 10 volts if you want to use all of those output voltages. So just as a last test, let's disconnect our power supply and turn it off. And I have a 12 volts battery pack in here. So as you guys can see, it's 3 cells, and I'll be using I have an adapter, power jack. So I'll be using the power jack connector to provide 12 volts to this board. So let's try now 2.5 volts. So 25018. Now let's 5 volts, 5002, 7.5 volts, 75049, and for 10 volts, that's the last output voltage, 100029. So if you provide more than 10 volts, actually I would recommend at least 12 volts. Doesn't matter if it's coming from a battery pack or your power supply, you should have really precise output. So now let's check the second one. This one is off. Let's put this battery pack aside. So this one is supposed to be more precise, the variation L. As I said, variations J, K and L can be found in the Chinese market, and the variation I found the variations J and L, and yeah, as I said, $4 this one, $2.30 this one. I put the link of both modules in the description, but for this price I think both of them it's a must have. But let's see how precise is this one. So let's input the voltage in the left hand side of the module. I'll be providing 12 volts in this case, and let's connect our, I'm gonna put this one aside. I'm gonna be using just my benchtop multimeter. So let's connect the leads of the benchtop multimeter here. So it's in the first range, output 2.5 volts. So now let's put back 12 volts in the power supply, and let's turn on the output. So 2.5 volts, and the output is 24987. Since this one doesn't have a on-off switch, I'll be turning on and off in my power supply. Shouldn't be a problem to swap the jumper while providing power, but to not affect our measurements, I'll be doing that. So now 5 volts, turn on. So at 5 volts the output is 49961, 49961,960. So this one is still more precise so far. So let's see now, it's 7.5 volts. So it's 7.5 volts, the output is 74987. And the last one, 10 volts. The output is 99955. It's still quite precise if you consider the price of these modules. Just $2.30, but with a little bit more money, for $4 you can have one spot on. That's this module in here. Let me do one last test. Let's provide 5 volts for this one. So 5 volts, and let's see at 10 volts if we get anything close to 10 volts. So in the same way, if you provide less than the output voltage, the module is not going to boost the input voltage. So you should provide, I would say, at least 12 volts, so you can trust your measurements. Turn off. So that's it, guys. Quite short video. Those 2 modules based on AD584, and for electronic hobbyist needs, they are quite accurate, and for this price you guys should have some of those modules around. So that's it for a while. I will catch you in the next video.